In this video, I'm going to prove that there is an infinity of prime number. So first of all, what is a prime number? A prime number, it's a number that has only two factors, and so can be divided only by itself or by 1. So for example, 2 is a prime number, 3 is a prime number, 5, 7, 11, etc. So we can see we know already a huge number of prime number. So how are we going to prove that there is an infinity of this prime number? So we are going to prove it by contradiction. We are going to assume, so the assumption is that there is a finite number of prime number, finite number. So for example, we are going to call them P1, so which is equal to 2, then P2, which is equal to 3, etc. And the last one, we don't know which number is it, but there is a finite number of prime number, we are going to call it Pn. Okay, so this is our assumption. There is only P1, P2, etc., Pn prime number. And now we are going to build another number, x, which is equal to P1 times P2 times P3, etc., times Pn, and we are going to add 1 to this multiplication. So what we can see for x, for this number, we can see that by construction, x cannot be divided by P1, because when we divide x by P1, the remaining is 1. And the same for the other prime number. So what does that mean? It means that either we have two possibilities. Either x is a prime number, or there exists a number p, which is also a prime number. There exists a prime number p greater than P1 that divides x. Okay, so these two are not contradict. These two contradict the fact that we have assumed that there is a finite number of prime number. So it means that so we can conclude that our assumption is wrong, and so there is an infinity of prime number. Okay, one thing, so where I make the proof, I want to also to show something. I want to say something else, because I've seen very often that people make it wrong, is that the number x by construction is not necessarily a prime number. Well, what we have concluded is that either x is a prime number, or either there exists another prime number that is greater than Pn that divides x. So x is not necessarily a prime number. So if we take, so it works for the small number, so if we take 2 times 3 times 5, which is equal to 30, okay? And if we add 1, so we got 31, so this is our x. 31 is a prime number, so in that case it works. But there are cases where it doesn't work. So for example, if we do 2 times 3 times 5 times 7 times 11 times 13 times 17 times 19, okay, and we add 1, this number is not a prime number, because it can be written, let's see, you to figure out, it can be written as 331 times 571 times 32,231. So this number x here is not a prime number. So we have to pay attention when we do the proof of the prime number.